We all good with the AV? All right, awesome. Well, welcome everybody. This is Docker 101, Meet the Portable Future. We catch your tagline, right? That's totally original by me. How are people enjoying the conference so far? Good, awesome. I think these facilities are amazing. I wish I went to school here. So a little bit about me first. My name's Andrew.Baker. I do consulting in Washington, D.C. I co-organize the Django meetup there, which is where I tutorial before.
Sorry for interrupting, but we're missing a good 2 to 3 inches.
Oh man, my plan to just bump up the screen size didn't work. Okay. Let me know if you have any more problems. So this winter, I worked on a side project, which was sort of learning about Docker by building my own platform as a service powered by Flask and Docker. And so that's how I got into this, and I think Docker is really, really cool, and I'm here today to maybe convince you that it's cool too. So you can find me on Twitter. There's my blog. This presentation is on slides.com, and there's a repository on GitHub. That's for the tutorial portion of this session. I'll have links for these up at the end of the presentation also. So let's talk about you guys. Who here has heard of Docker before? Okay. Who here has used Docker before, like tried the tutorial or something? Is anybody using Docker for their day job? Wow, okay. Is anybody using Docker like in production in their day job? Awesome. Really, really cool. Maybe if we have time at the end, I'll ask you to like talk a little bit about what you guys are doing. Great. Well, this tutorial assumes that you don't have any prior knowledge with Docker. It's something that's got so much hype and buzz that it's hard to tell exactly what it is. So my goal in this presentation is to cut through the hype, and hopefully you can learn something, this really cool, new, exciting tech. So today I'm going to start with a short presentation covering the basics of Docker, the vocabulary, some of the sort of basics of using Docker in your development workflow. And then most of the session you're going to spend working through a tutorial repository at your own pace. Really informal and collaborative. Kind of be working through it around questions.
We don't.
Free to raise your hand and pop in with a question at any time. So we'll probably do about like 20 or 30 minutes of this slide content, and then we'll switch to the tutorials content. And we're here until 4 o'clock. So what is Docker? It's reading about it. It's exactly what this thing is. Is it a virtualization tool like VirtualBox, where it's actually a virtualization provider? Is it a configuration manager like Chef or Ansible that you're using to manage, you have? Is it something like Vagrant, where it's just helping you manage all your VMs? Some people have also described it as fancy C groups. That's sort of the low-level Linux foundation that Docker is built on top of. Or you may have seen the phrase LXC, which is Linux extension containers. So the answer is that Docker is something new. Docker.io officially defines it as an open source engine that automates the deployment of any application as lightweight, portable, self-sufficient container that can run virtually anywhere. So I think it's best to describe it in terms of sort of a spectrum of application portability. So all the way on the left, you have sort of an environment-specific configuration. So this is where you have a server. It's a bare metal server, in your server closet, or it's an EC2 instance that you got on Amazon. And you're starting from scratch just with an operating system and going in through your shell and manually configuring your server. So you're adding in, maybe JUnicorn for running a Django app, maybe Nginx to do some reverse proxy stuff. You're manually installing Postgres. If you go a little bit further along to the right, you have configuration management tools. So these are things like Chef or Puppet or Ansible, where you are describing to them what state you want the server to have, what tools, configuration, et cetera. But that configuration management tool is actually handling the details of going into the server and making your configuration a reality. is I call environment agnostic, which is more like traditional virtual machines. So this is like if you were running a virtual machine using VirtualBox on your laptop. Your laptop could be running any operating system, and the virtual machine that you could be running could be any operating system. They're totally separate and distinct. You fire up that virtual machine. What VirtualBox is doing for you is creating an entire environment so that that virtual machine thinks that it's a real machine, complete with duplicated code and all that. So Docker is somewhere in the middle, where it provides the isolation of traditional virtual machines. So when you're running a process in a Docker container, it's running in its own operating system that's isolated from the host operating system. But it doesn't duplicate, it doesn't need to duplicate all the processes handled by your host operating system. So docker.io has a nice chart which sort of describes the difference. On the left side is a diagram which is describing how traditional virtual machines work, and on the right side is describing how containers work. And containers are sort of the language for running a Docker process. So you'll see on the left, or rather on both, you have server, which is a machine, and then you have a host operating system. But on the left, you have a hypervisor, so that would be something like VirtualBox. And then for each application that you want to run, you have to duplicate all of the work and memory and processes involved in running the guest operating system machine. On the right side, you'll see that the containers are a little bit different. They don't need to run the guest operating system portion because they rely on aspects of the kernel of the host operating system. So this makes Docker containers really lightweight compared to traditional VMs because a Docker container doesn't have to duplicate all of the functionality of a guest operating system. It can sort of leverage the functionality of the host operating system, but still keep your application isolated. So that those guest OSs takes up a lot of CPU and memory and makes running traditional. When you're running a container, you really are taking it down just to the libraries that you need to run your application code and the application process itself. And one of the nice things about Docker is that it uses a copy on write file system, so you can almost get Git style version control features as you are using Docker containers. You'll sort of start off with that first version on the left, and then as you sort of modify it over time, it's just tracking the differences between each container instead of the complete code for each of them. So this is a traditional, typical Docker architecture where a Linux kernel sitting at the bottom, and that's just operating system, could be Ubuntu or CentOS, Red Hat. When you install Docker, it runs the Docker service or the Docker daemon, and then you have a container running, a Docker container running for each process in your application. So for us, from a Python perspective, for those three processes there, maybe the software load balancer would be something like Nginx. The application server would be something like gunicorn, serving up your Django application. And the high availability storage service, that might just be your Postgres database, or maybe a Redis instance or something like that. So the rule of thumb is that in Docker, you isolate each process that you need to run for your application in its own separate container. So in this example, if we had one container running Nginx and one container running gunicorn and one container running Postgres, we would have 3 Docker containers that are running our application. So why is this a big deal? This is a big deal because it has to do with the commoditization of computing services. So the idea with Docker is that as you're preparing your application to live in this container, you as the developer sort of wire up everything inside this little box the way you want it to be, and then you can take that box and give it to anybody who is running a server that can run Docker, which is increasingly almost any kind of modern operating system. And you can have confidence that everything inside that container is going to behave exactly the way that you packaged it up in that box. regardless of how your hosting provider has configured their servers, what libraries they're using, if they're using MySQL version A versus version B, none of that matters to you because your box is packaged up in a way that you will have complete isolation. But because you don't have to duplicate that whole guest operating system of a traditional VM, it's a lot cheaper for hosting providers to take your box and host it somewhere. And so the reason why I think this is really exciting and because it's going to be a big deal is because if people start using Docker to package up their applications that way, and I have my little box, it doesn't really matter who I host my box with. So it's very easy for me to switch between hosting my box on Amazon or hosting it in DigitalOcean. There are even lots of Docker-specific hosting providers cropping up, like Orchard and Tudum, which are just taking your containers directly from you and running them sort of on their own virtualized hardware. So it reduces the cost for you as a application for moving in between these different services. And the easier it is to move in between these different services, then the more reason those different hosting providers have to compete. And then hopefully that drives prices down and we all win. And you kind of saw a little bit of that action earlier this year when all the big cloud hosting providers started dropping their prices a little bit. And they're starting to realize that they all have a little bit more competition with each other than they used to, which is good news for us because it means we can run our apps for cheaper. So that was kind of the overview of Docker architecture. I know it sounds probably weird, and I think it'll be a little bit easier to understand once we start going through the examples, but does anybody have any questions just through that first bit? Yeah?
How useful is that?
Oh, sorry, got to get on the recording.
How useful is Docker for an individual developer, say for using as a sandbox, the way low-impact virtual systems might be used in the past?
Yeah, that's a great question. It's definitely something that people are recognizing as a great application or a great use case for Docker. There's a tool out there called Fig, which you're going to work with in your tutorial today, which makes it very easy to run a local development environment using Docker containers. I read a somewhat provocative article, I think it was on Hacker News a couple of weeks ago, that was saying maybe Python developers should abandon virtual envs in favor of running your development code in a Docker container instead. And I don't know, I'm a Python developer first and a Docker enthusiast second, so I don't know if I was quite ready for that leap, but it's something people are talking about.
Could you compare the two?
Yeah, I think with virtual envs, the crux of this person's argument was that virtual envs allow you to get Python level library isolation from your host operating system, but they don't let you get sort of like operating system libraries isolated. So there's a chance that maybe there's like some XML library on the host operating system or some other non-Python dependency that would be different on the tool, on the machine that you develop on versus the machine that you run your code on in production. But I don't know, in all the years I've been doing Python development, I haven't really been shot in the foot much by differing operating system level dependencies. And since Docker is still so new, the tools for using it aren't necessarily as mature as virtual env is. So I guess that's why I didn't think that maybe we're not quite ready to make the leap away from virtual envs just yet. They're just still too easy to use. Anybody else? Okay, cool. So now we'll talk about some of the basics in Docker terminology and the basics of a Docker workflow. So the two main concepts in Docker are containers and images. Applications run in containers. Processes, your code, runs inside a container. And to create a container, you need a Docker image, which is basically just a file system for an operating system and the code you want to run, your application code, and the command that you want that container to execute. So in this example, we're using the docker run command on the terminal to run the Docker image called busybox, and we're just telling it to run the command echo foobar and store it in a file on temp/foo.txt. And so when you run this command from your command line, Docker will take the image called busybox and execute the command echo foobar inside that image, we're using, just pipe it out to temp/foo.txt. And so after that, you have a container which was originally based off the busybox image, but now has been modified because there's this new file in it at temp/foo.txt. So if we wanted to save that change so that we could take that change to a different server, so for example, if we were making this change in development and we wanted to take it up to production, we would need to commit that change into a new Docker image. So containers stay on one machine. The good rule of thumb is that containers stay on one machine, and images are what you use to move your changes around to different environments. So if I wanted to save this change that I made to my busybox container, I would say docker commit, add a message saying I added foo.txt, the hash of the Docker container that I ran it in, which you'll see how to get that. It's very easy. And then I give it a name, so I'm going to call it AndrewT.Baker/foobar. That's just the name of my new image. And then if I wanted to go and deploy that in production, I would log into my production server and say docker pull AndrewT.Baker/foobar to bring down the Docker foobar image to my production server, and then I would be able to run it and see that change in production. So again, this will be a lot more evident once you guys start going through the tutorials. So doing this, run a command in a container, then committing it into a new image is one way that you can build up changes for your Docker images. The other way is using a feature called Docker files or the Docker builder. And what the Docker builder does is it's essentially just a script with a series of commands that you want to execute all at once. So instead of having to create a new container, run one command and then commit it into a new image, you can tell Docker, just go ahead and run all these commands at once and then commit it into a new image. And so for people who are deploying Docker into production, most of them have a Docker file that they're using so that you can sort of predictably and reliably build up your code, build your application environment. And you'll have a tutorial that goes through working with Docker files. So there's also this thing called the Docker Hub. It was previously called the Docker Index, if anybody's been following Docker for a while. The Docker Hub is kind of like the GitHub for Docker, where it's just a place where everybody seems to Docker images, their Docker code. And so you can see that there are some official repositories. So if you wanted to add a Redis instance to your application, you could use one that's officially been configured as a Docker image by the good people at Redis. Same thing with WordPress, MongoDB, all the sort of big appliances that you'd expect. So I like to compare Docker as kind of like a Git for deployment or a Git for configuration, where in Docker an image is kind of like your repository in GitHub. It is just a collection of commits. So you started from some base image in Docker, just like maybe you would initialize a Git repository, and then every change that you make to it, whether you're doing that sort of create a container, commit it, and save it workflow, or if you're using a Docker file, every change, every commit, Docker is just recording the difference between the new commit and the previous commit. So a Docker image is like a Docker repository, and you can look at the logs on a Docker image and see all the commits and what happened in them. You can roll back a Docker image to a certain point in time, just like and check out a specific SHA on a commit in Git. So if images are like repositories, then containers are like clones. So a container is what you are using to execute your Docker code locally, whether it's on your development environment or if it's on your production server. So just like with Git repositories, you clone it onto whichever server that you want to work with it on, right? So you have a clone on your development machine, and you have a clone on your production server. And when you want to change, deploy some updates, you commit your changes on your development machine, push them up to GitHub, and then pull them down onto the server. In this case, you commit your changes on your development machine to your Docker image, push those changes up probably to the Docker hub, and then pull them down onto the server as a new image, or as a new commit on the existing image, and then run them on the server. So the last piece there is that the Docker hub is like GitHub, and they used to call it Docker hub, and I think they did that partially because they wanted people to make this association, where the Docker hub, GitHub, is just, you can run your own Git server and it's no big deal, but GitHub is the place where many, many people seem to keep their code. It's the same thing with Docker, where the Docker hub, where, you can save your Docker images, keep them wherever you want to keep them. They've even open source all the code that they use to run the Docker hub. So you could run your own Docker hub if you wanted to, if you were running a pretty big scale operation. But Docker, the company's business, is kind of like GitHub, the company's business model, where they are trying to make Docker Hub so easy to use and have so many nice extra features that you're willing to keep your Docker images on the Docker Hub and pay for some of their extra services, like private Docker images and things like that. So does anybody have any questions on that section? Yes?
Yeah, I wanted to know if I understood what you were saying right about the Docker builder. That basically allows you to programmatically create a script that will create an image.
Exactly. That's
okay.
Precisely. Anybody else? How are we feeling? Is this making sense? Okay. Cool. So part of the reason why Docker has so much buzz is because it's a really cool open source success story. So it was started at a company called .Cloud, which, if you remember them, they were viewed as like a Heroku alternative, where they would take your code, just your raw and you would sort of run it in their equivalent of like dynos, and you would have the little slider on the configuration panel which says, okay, I actually want like 10 web servers now as opposed to 2 web servers. But they weren't really making a lot of progress against Heroku. So they decided to open source a lot of the guts of their business, which is running a platform as a service and doing it in a way that's very efficient, as a business. So Docker was revealed as a side project at PyCon 2013, and it just really took off since then. People sort of realized that this was part of like the secret sauce of Heroku and other similar services that were running platform services. So it's been downloaded a ton of times. It is part of tons of projects. Many, many contributors to the Docker core code itself. It's got tons of GitHub stars, which is like everybody's new favorite metric for how hot their open source project is. And .Cloud officially changed its name to Docker, and its business model now, it is not in the business of hosting your own application code anymore. Its business is sort of extra services that you will pay for related to the Docker open source project. And so for a long time, Docker was not at version 1.0, and there was this big red box on top of all the documentation that said, you can use this in production, but we don't know what's going to happen, so don't blame us when things blow up. But it didn't stop people from building tons of stuff and putting it in production anyway. But they finally released version 1.0 in June 2014. So this is a really, really good time to give Docker a try, because they sort of just went through a really big on adding quality to the code, the tools that it comes with, all the documentation. So I think we're only on version 1.12 right now or something like that. So things are still moving fast, but people have sort of recognized that Docker has kind of reached a level of maturity where it's ready for widespread adoption. So Docker kind of describes their ecosystem as this, where on the top half, you can use Docker to run any kind of app. And these are sort of all the different web services that are using Docker to power their business. And pretty much ever since, I don't know, Docker started making it big about a year ago, a lot of big services and a lot of big hosting providers realize that this is something that they need to be a part of, or else they're going to get left behind. So you'll see a lot of big names on the top half of this chart and the bottom half of this chart. So Docker kind of separates itself into the engine, which is all of the projects you need to run your Docker images and containers locally. That's everything we've been talking about up to this point. And the Docker Hub, which is sort of that GitHub hosted, remote service that you can use to store your Docker images and fork other people's Docker images and stuff like that. But the piece on the bottom, I think, is the most interesting piece. These are all of the services that are starting to support Docker natively. So when Docker was a little earlier in development and you want to work with it, basically Ubuntu, that was the one that you would use. And the 12.04 long-term support operating system, or version rather, you had to install like a slightly newer kernel because the kernel that shipped with that one in like 2012 didn't have all the services that Docker needed. But now it's like everybody and their mom wants to run Docker because they know that once you wire up your little box, you can put it anywhere, and they want to be that place where you put it. So Amazon Web Services will now had Docker integration with their Elastic Beanstalk service, which is pretty cool, which can kind of give you a nice middle ground between configuring your application exactly the way you want it at an operating system level inside your Docker container, but then using the Elastic Beanstalk to kind of get that slider, which is dynamically provisioning, instances to run your web server, as many as you need at a time, which is pretty cool. There are also some Docker-specific hosting services out there, like I mentioned, like Orchard and Tutum, which I'll talk about more in a little bit. But all the big operating systems, or rather the Linux operating systems, are starting to support Docker out of the box. As always, the version that comes officially with the OS is probably not the most up-to-date version of Docker. And this is definitely an open source project that is moving quickly. So if you are configuring it on your own, your own stock operating system, I would recommend doing the custom install anyway to make sure that you've got the latest stuff. So this is a really cool chart. I think I'll try and make it a little bigger without blowing it off the screen. These are all the Docker meetup groups as they start happening in the world. So the left side of the x-axis is 2013, and the right side is March 2014. And the purple one going up the top are international meetups, and the blue ones sort of going off to the side a little bit are in the United States. And like I was mentioning to some people earlier on, I think it's really cool that Columbus is basically right in here, which is pretty early on as far as Docker meetups go. So that's awesome. And if any of you here are local, I think you should definitely be hanging out with other Docker people here in Columbus. I would do it if I was around. There's a DC one too, but we were like 3 cities behind you. And St. Louis beat us, so I mean, we got nothing. Yeah.
Just curious, looking at that graph, that looks like the international one is sloping up, and the US one might be even starting to slope down with a definite crossover point. And I'm curious if you have any theories about that.
No theories in particular, other than, all these international big cities. So I think it's just
number of cities.
It is definitely an imprecise. It's definitely an imprecise diagram. Okay, so what are people doing with Docker? The answer is tons of stuff. One of the cool environments. Oh, right. There we go. Thank you. So development environments, there's a tool called Fig, which you will use in your tutorial today, which makes it easier to manage all these Docker images and containers when you're working with multiple ones on the same machine locally. It's really cool, actually, because Fig was one of the first open source projects built for Docker, which kind of made it big. And the two developers behind it officially joined Docker like earlier this week. So these are going to be sort of like officially in the Docker ecosystem now, which is really, really exciting. And it's built on Python, so it's like another win for Python stuff. Docker itself is built with Go, so you know, I don't like hearing about comparisons between Go and Python. So platform as a services is one of the most obvious applications for Docker because that was the role that it served at DocCloud before they open sourced it. So there was one called Doku, which made it big early on, which is, you know, sort of the bare bones platform as a service that you would need, just written in Bash. But that project has kind of fallen off the radar a little bit. And the two big players right now are called Flynn and Days, or Day. Flynn seems, or Days rather, seems to take the batteries included approach, where Flynn is more of the highly configurable approach. So if you get through all the introductory tutorial material today, you'll be able to take a look at these two and check them out and make your own opinion. But with both of these, the idea is that if you needed to open that business, you know, run a business like Heroku, or if you needed to do it, maybe you work at a really large corporation and you need, you know, your developers to be able to spin up demo environments really, really quickly, you could run one of these services, and they handle all the logic of taking raw application code, packaging it up into a Docker image, and then deploying it out on a server that's running Docker where it can be hosted. So it's really, really cool because, like I said, this was sort of like secret sauce in the hosting world for a long time, and now it's really easy for anybody to do. Continuous integration is another really cool one. So continuous integration is where you know, you're using a separate hosted service to run more isolated tests on your code, and because with Docker, you don't have to pay for that whole guest operating system to get the full isolation that you would need for a valid continuous integration test. It's an obvious application for Docker. So Drone is a company that's sort of got a head start on everybody else, but I imagine that other big CI services are going to start experimenting with Docker soon because it's cheaper for them to use Docker to do their tests than it is to stand up a whole virtual machine just to get you the isolation that you need for valid testing. Educational sandboxes is a big one. So this was sort of the front end of the Docker side project that I did this winter. At my company, I teach a database, intro to databases class sometimes, and I thought I was going to be really smart when I ran the first iteration of the class and give every student their own database. And so I went to my web host, which is just a traditional web host, and I said, give me like 12 that I can use for my class, and I got all the databases and I loaded them in with the SQL code that I wanted to use for the class, and I tested it out the night before, and it's like, yeah, all these databases are looking great, this is so awesome, I'm gonna like redefine database learning by giving everybody their own database to play with. And then we got to the class and my web host saw like 12 different people trying to connect to the back ends of web applications, all from the same IP, and it just blacklisted all of us immediately. And I was so furious about that, that I spent like the next 4 months building something with Docker on my own so that I would know that that would never happen to me again. So the purpose of this site was just to give you a database on the fly, like really quickly with a Docker, using Docker on the back end for people to experiment and play with. So my database classes are much happier experiences now. And I've stopped hosting with my crappy web host. The other exciting thing is that the tools for using Docker are getting better too. So people are starting to build some GUIs around it. Shipyard is a big one that's, I would say, like semi-officially recognized by the Docker, the company. There's also cloud hosting, like I've mentioned. So Orchard is one that just officially became part of the Docker family when do Fig were a part of that. And then this is another one called Tutum. So Tutum asked, full disclosure, they asked me to evaluate their service. And I thought it was pretty good. And there's an email address at the end of this presentation. So if you want to get additional free credit beyond just the little bit of free credit they give everybody for signing up, you can do that because you came here to my tutorial. So the idea of Tutum is that you are giving them your Docker image and they are running the containers on their own hosted hardware. So you just need to wire up your box and give it to them, and they handle everything else. And I really like their tagline on this because they say AWS-like control, but Heroku-like ease. So with Docker, you can take your box and wire it up exactly the way that you want. You get all the configuration for your database level, for the operating system level dependencies. There's nothing that you can't configure about how your application will behave. But if you're just running Docker containers on your own, then you kind of lose that awesome little scalability slider for when things get heavy on your website. So Tutum and Orchard give you the best of both worlds, where you can wire up your container exactly the way you like it, but they're taking care of all the hosting mechanics for you so that you get that little slider back and can increase or decrease your services as much as you need. The really exciting thing about Docker is that things are getting better all the time. So Docker is officially included in Ubuntu 14.04 and lots of other Linux operating systems now. But like I said earlier, it's not always the most recent version, so you should follow the installation Docker documentation. I mentioned the Elastic Beanstalk support. Vagrant has official Docker support now if you want to use Vagrant to manipulate your Docker images. They had their first DockerCon in June in California. I was bummed that I missed it. I'm sure it was really cool. And the Fig and Orchard team officially joined Docker. So those are two of the best tools in the Docker ecosystem that we know for sure are going to be supported going forward. So they have a Docker Weekly email newsletter, which is a great way to stay in touch. It highlights official announcements from the company and really cool projects and blog posts that people are doing stuff with Docker. Recommend it. So does anybody have any questions? Otherwise, we can get to the tutorial stuff.
Orchard?
Yes, what is Orchard? Orchard is kind of like Tutum, where you give them your Docker container and they handle all the hosting arrangements. And now that it's officially part of the Docker ecosystem, I think we're going to see a lot more action coming from that service. Yes?
You mentioned that the Docker images need to be committed to save the data. How are you handling the persistence, like with your database containers and such?
Yeah, that's something that I still haven't figured out yet.
I'm sorry, I didn't hear your question.
Oh, right. Sorry. The question was, when you are committing Docker containers, how do you handle persistence in things like databases and things like that? So the idea is you have your database running in production, and things are happening in there, data is changing, but you need to still, if you wanted to change your database, you would need to make a commit of that container on production and then bring it back as an image, further back. I don't think, I could be missing something, but I don't think we've figured out like what the best practice is in that area yet. So when I've played with Docker trying to run a site, I still use like a separate service for hosting the database part, like Amazon RDS or something like that, so that I don't keep my database in a container.
If you could, just let me pass you the microphone.
Any other questions? Certainly this won't be your last chance. Once we start on the tutorial content, you'll be able to grab me whenever you want.
I'm just wondering how the hosting services, like the hub, are handling people committing sensitive information if other people can pull those images. So SSH keys, things like that.
Yeah, that's a good point. I think right now, it's sort of at your own peril, maybe. I'm not aware of any mechanisms they have in place to help kind of safeguard you from shooting yourself in the foot on that kind of stuff. One thing I've noticed, though, is, because this is embarrassing, I got an email from Amazon Web Services a couple weeks ago telling me that like one of my access keys was in a public repo on GitHub, in one of my public repos on GitHub. So that was really nice of them to tell me that. I took it down and changed all my access keys. But maybe big services like that will start crawling the Docker hub as well to kind of help you out. Any other questions? Okay, so we'll get into it. So there are kind of two sections to the tutorial. There's an introductory section and an advanced section. The introductory section is the section for people new to Docker, and I recommend that everybody go through it unless you really are using Docker every day. It covers the basics of working with Docker containers and images. There's a sample Django project in there that you will build, or rather complete, a Docker file for, so you'll get to see how the building Docker image that way works. And you'll get to go through the tutorial for Fig, so you'll get to see how you would manage your development environments using Docker. And if you can easily manage your development environments using Docker with Fig, then those hosted services like Orchard and Tuda make it easy to deploy your Docker images on real hardware for production. So you would basically, exciting. So if you finish the intro tutorial, then you can go through the advanced content. It's more like a survey of interesting Docker projects, some of them that I mentioned in the presentation. So you can see what's most interesting to you and just kind of check it out. But I imagine for most people, you will probably spend most of your time just working through the introductory material. So here is the repo's URL. And for the tutorial content, you need to have access to a machine running Docker. So I have a Vagrant file in there if you want to use Vagrant to provision your own machine using Docker, rather using Ansible to get Docker on a virtual machine. There's also installation instructions in the official Docker documentation, but I really hated it when I went to tutorials like this and configuring your own machine was like half the battle. So I have 20 medium Amazon EC2 instances sitting out there on that cloud server signup sheet. It's just a Google spreadsheet, and it has the exact SSH command that you would need to access the server. It uses a sort of insecure SSH key that's part of the tutorial repository, so you would still need to download the repository first. But then you can just go onto the spreadsheet and put your name next to one of those servers, and it's yours for the rest of the session. So if you don't want to mess with like trying to install anything, I recommend you grab one of those. Unfortunately, I only have 20, so if you think that's going to be you, I would recommend grabbing one soon. But the last thing I wanted to say is that there's only one of me, so I will, if you need help from me, just go ahead and raise your hand and I'll come over and talk things over with you. But obviously there are like 40 of you, so I think we're all friendly here. Just, try and help each other out if you see somebody getting stuck. And then we'll, reconvene at the end and talk about how it went. Yes?
Are these going to be around after today?
The question was, are these going to be around after today? And yes, those two links are going to stay the same forever. If you are using one of my cloud servers, I'm going to shut those down at the end of the day just because that's expensive. Does anybody else have a question? Okay, great. I'm going to leave this up here. Thanks, and we'll talk again at the end. Thank you. Could we turn on the lights maybe?